All right. Let's go ahead and take the derivative of that thing. So we got to find the derivative of the function. It doesn't look like there's anything fancy going on, right? No, it's just a really straightforward derivative. So what's the derivative of 15t cubed? And then the derivative of 6 secant t is secant t. And look at your answer choices. It helps you out, right? You do need to know it, though, at least by sight, because you got to know if it's positive or negative. Okay, so it's looking like it's answer choice E on that one, right? All right, we good with 20? I'm waiting. Okay, 21. It looks like we've got a product rule in the middle of it, right? Because I've got a variable times a variable. So we got to do product rule. So I'm going to keep the first. What's the derivative of the second? Cosine v, right? And then I'm going to keep the second, which is sine v. And what's the derivative of 7v? 7. And then I also have to take the derivative of this back piece. So the derivative of cosine is what? Negative sine v. And since these are the same like terms, I can put them together. So 7v cosine v. What's 7 sine v minus 3 sine v? 4 sine v, and it's looking like D. All right, we good with 21? Okay. We got to find the second derivative. Okay, so that means I'm going to probably have to do that product rule a couple of times. So h prime of x equals, keep the first, so h to the fifth. What's the derivative of the second? That's nice. This one's, I think we may have crossed this one out, actually. Let's see what the first derivative does, and then I think it gets really ugly after that. Plus, we keep the second, right? Which is secant x, and the derivative of the first is 5x to the fourth. Okay, what we would do with it beyond that is probably factor something out and then try to take a derivative again. I don't know that this one ended up on the final, okay? My guess is probably not. But let's be safe rather than sorry. So it's 4 secant x, right? So you'd be left with x tangent x plus 5. Which is a really ugly product rule. We're not even going to try to simplify it. Because look at that. I've got... Oh, I don't think I can even do that, right? Because look at how many products do I have. Yeah, we're going to take this one off. That's as far as... We're going to change this question. First derivative. Okay? And we're going to... I'll double check the final and make sure that that one's not there. Okay? At least in second derivative form. Alright, let's look at 23. What rule do I need on 23? Chain rule. So I'm going to start by taking this and moving it to the front. So f prime of t equals 8 times 1 plus 2t to the 6th. And then the derivative of the inside is what? 12t. And then 8 times 12 is 96t times 1 plus 2t to the 6th. Oh, I lost an exponent, didn't I? Should have been a 7th power right there. But looking at your answer choices, there's no way to get anything but a 7th. And I lost a power here too, didn't I? Not doing so well this morning. Because it should be a 5th power on that. Alright, so 96 to the 5th, and it's a 6th power on the inside. It's that one, isn't it? Yes. You have a really nice car. I have a really nice car? Yeah. Thanks. That's why you could get a good education and a good job. Mm-hmm. Do you know how long it took me to get that car? I didn't even get a new car for myself until my second child was almost born. So, yeah. I drove the car that my parents gave me to drive to college, so. For a long time. Alright. think that one finally is almost paid off, so.
It's brand new too.
It's not. It's 5 years old now. Take good care of him, too. Alright. So, let's take a look at this one here. We've got to take the derivative, so y prime equals. I'm going to just keep that -4 up front. What's the derivative of cosine? Negative sine 6x, and then we need to do a chain rule derivative in here. What do we get for that chain rule piece? 6. So double negative is going to go what? Positive, and then I got to multiply the 4 times the 6, which gives me 24 sine 6x. So D. Does it say oh, I'm sorry. I wasn't reading. It's not C. It's A. Alright, yeah, see how easy it is to make the mistake? I made it. So you really got to be careful when you're choosing your answers, which is a good reason to write down some work, right? Okay, let's look at this one. So we got to take the derivative of this. So, and it's a derivative, not an integral. I am going to rewrite it before I take its derivative, because it's got chain rule all over the place. 5 pi t minus 2, and then all squared. So I'm taking the squared from here, and I'm writing it outside. So this is still just f of t. All I did was rewrite it and move the exponent up, but you got to be careful. You can't write the exponent on that set of parentheses. It needs to go outside. Okay, so now we're going to take this 2, and where does it go? To the front. So I've got 4, and I write down the function exactly the way it looks. Thank you. It should be 8. I apparently can't do arithmetic this morning. Making mistakes all over the place. All right. Then, what's the derivative of secant? Secant tangent. So I'm going to write secant of whatever the mess is on the inside times tangent of whatever the mess is on the inside. And I'm not done yet, because I have a chain. It's a peanut butter M&M, right? The chain rule all the way on that inside. What's the derivative of 5 pi t minus 2? 5 pi. Okay. Looking at what we have now, what would 8 times 5 pi be? Which makes sense looking at our answers, right? It's definitely not C, it's definitely not D. Aren't these two the same thing? So can't I square it? And it's all multiplication, right? Even though I have a lot of parentheses going on, it's all multiplication, so I don't have any weird factoring or addition or any of that. And then tangent of 5 pi t minus 2. So let's see. It's not, oh, this one doesn't have a pi. That one is this one right? Is it A? What's the difference between A and D? Oh, yeah, this is all backwards in this one, isn't it? Yeah. It's really subtle. It would. Okay, let's look at 26. So, equation of a tangent line. What are the two things we need for a tangent line? Point and slope. We have a point. What do we need to get? Slope. How do I get the slope? Derivative. And look at your slope choices. It's either 108 or 54. All right, you only really have two choices. All right, I'm going to take this and I'm going to move it to the front. So we've got 2 times 2x cubed plus 7. And then chain rule. What do we get for the chain rule? 6x squared. I wouldn't try to simplify that, because look at what number I get to plug in. 1. Don't bother simplifying. Just use the 1. So 2. Let's see. 1 cubed is 1. 2 plus 7 ends up being what? 9. 1 squared is 1. 6 times 1 is 6. All right. 9 times 2 is 18. 18 times 6 is... It's got to be 108, doesn't it? Yeah, because look, 9 times 6 is 54. So double that. It's got to be 108. And it's positive 108. So it's either got to be A or B, probably. Okay. So I'm going to go into point slope. So y minus, what's our y value from our point? 81 equals 108 times x minus what? 1. All right, we would distribute this in. So y minus 81 equals 108x minus 108. I have to add the 81. Okay, so we know we've got the positive 108. I'm either going to come out with a positive or a negative 27. So think about that. If I'm going to add 81, is it going to be positive or negative? Negative. I don't even need to really understand that it's 27. I just need to know it's negative. Yes.
Are you always going to give the points at 1 and 81?
If they want you to find equation of the tangent line, they need to have it there, yes. Okay, either that or you need to be able to develop it. They need to at least give you an x value or a y value to be able to figure out the other. Likely the questions are going to be very similar to what's here. Okay? Yes, Sage? Nothing? Okay. All right. 27. We got to go to the second derivative, and I'm going to guess there's some weird factoring going on here. Okay? So let's go first derivative first. So I've got to take this 3 and put it where? To the front. So I've got 3 times 2x cubed plus 1 squared, and then I got to chain rule it. What does the chain rule give me? 6x squared. I would simplify that before I try to take the second derivative. So what's 3 times 6? 18x squared times 2x cubed plus 1 squared. Here's where it gets ugly. Now I have a product rule. This time it's not as bad as that last one that was that one that was really ugly. So we're going to keep going. So keep the first. Derivative of the second. So what's the derivative of this here? Where do we put the 2? In the front. So we've got 2x cubed plus 1. What's the derivative of this inside here?
6x squared.
Okay. Plus, and I'm going to run out of space. Sorry. I'll clean that up in a minute. We're going to keep the second, which is the 2x cubed plus 1 squared, and take the derivative of the first. What's the derivative of 18x squared? 36x. All right. Let's clean it up a little bit and then see what we can do to actually try to get our answer. Okay? So let's see. I'm seeing... In fact, I'm just going to multiply 2 times 6, which is 12. X squared times x squared is x to the 4th. I'll show you why I did that in a minute, okay? And then we've got this 2x cubed plus 1 plus 36x. I should have gone further in the other way. Cubed plus 1 squared. Okay. Look at what they pull out. What do they pull out? They pull out an 18x, right? And then they also pull out, notice this here is the same as this, but written backwards, isn't it? They also factor one of those out. All right, so let's see what happens with that. So we're going to pull out, oh, I'm in highlighter mode. I want to be in this mode. So I'm going to pull out 18x, and I'm going to pull out the 2x cubed plus 1. So in this piece here, I'm left with 12x cubed. And that's this out of this whole chunk from here to here. Then in this chunk in the back, I see a 2. And then I have one of these guys left, right? 2x cubed plus 1 left. Do we see how we have the whole first part now?
Yeah.
Almost. These guys are gone, right? Because the cubes have to be in there. All right, so now I have to figure out what the back part is. I can distribute this piece. So 18x times 2x cubed plus 1. 12x cubed plus, what's 2 times 2?
4.
4x cubed plus 2. So what's 12 plus 4? 16x cubed plus 2. And remember, you're going multiple choice. Do I really need to write out these once I figure out the first part, I really only need to write this back part, right? So it's looking like B. You want me to explain it again? Okay. Do we understand how I got all the derivative part?
Yeah.
Okay, it's the algebra that kills us, right? Okay, let's look at the algebra. Let me go to highlighter. Let me switch to green, maybe. Okay, so what I need to do is, do you see in here how I have the 18?
Yeah.
So I found the 18x in here and here, and there's an 18 pulling out of there. Okay, do we see? And that all comes out. So left behind was, for the 18 was a 12x cubed in the first one. And in the second one, there was a 2. Okay, we see that part?
Yeah.
Okay, now I'm going to highlight in another different color. All right, let's see if it'll let me do this. So now do we see this piece here? 1 plus 2x is the same as this, isn't it? And I have that in there in both terms. So I pull that out, left behind in this first term, it's gone. Left behind in this term, there's 1 left. Okay? Then, only thing that's going to change now is I distribute the 2. Okay, so that's where this came from. I combine these like terms, and then that was it. Right? These guys, once I got, these guys didn't, these 2 in the front didn't change once I got it factored out. Okay?
Yeah.
Do we see it now? It's not the calculus we have a problem with, right? It's almost always the algebra. All right? So, and I'm not sure. I'll go back and double look at the final. I haven't gone back and looked at it to see if we actually make you do all that icky factoring or if we just leave it. Okay? We might just leave it for you. All right. This one we got to go implicit. So, implicit means, remember, we do dx, dx, dy, dx. So, what do we get when we take the derivative of x squared? Dx, dx, which I don't write down, right? Plus, what do I get for the derivative of y squared? 2y dy dx equals what? 0. Good. I'm going to move the 2x over. What do we get when we move the 2x over? Negative 2x. Okay, what do I do to move the 2y over? Divide it. So we've got negative 2x over 2y. Those cancel. I get negative xy. B. And a big hint on that one, you guys. No matter what square number I put here, aren't I going to get the same answer every single time I do that problem? Yeah. Oh, I still haven't fixed that. All right. Implicit again. A little bit uglier this time. We've got a product rule going on in the middle there. So, what's the derivative of x to the 7th? 7x. I don't know what I'm writing. 7x. Let's just go there. 7x to the 6th. Okay. Dx dx. What's the derivative of 2x? 2 dx dx. Here I need a product rule. So, plus, keep the first. What's the derivative of the y? dy dx. Plus, keep the 13 and the second, right? What's the derivative of the x? dx dx. I know it looks like a b. I'll fix it. Okay. 13. All right, and then now we still haven't done the derivative of that negative y to the 8th. So negative what? dy dx equals 0. All right, now we got to keep the dy dx's on the left, put everything else on the right. So let's see. I know I'm going to subtract the 7x to the 6th. I'm going to subtract the 2. I'm going to subtract the 13y. And then I'm going to be left with 13x dy dx minus 8y to the 7th dy dx. What do I do with the dy dx? Pull it out. You're going to factor it out. So we've got 13x minus 8y to the 7th equals negative 7x to the 6th minus 2 minus 13y. What's the last step in getting this to the other side? Divide it. And then we have to see if we have the answer there. My guess is we might have to play a game with the signs. Over 13x minus 8y to the 7th. All right. It looks like, well, we know it's definitely not B, right? We need all the signs to be the same. It looks like they're all the A is not all the same, right? So it's not A. It looks like, oh, look at the denominator here. So we got to get rid of that. So we're down to D and E, right? So it looks like we need to do, see how the signs are swapped on everything? So that means, what am I factoring out? A negative, but I'm factoring that negative off both the top and the bottom, aren't I? So I'm taking a negative out of the top, plus 2 plus 13y, and then I'm also taking a negative out of the bottom, which the way that they did it, they reversed their order, didn't they? minus 13x. So the double negative goes positive, so it is answer choice E. All right, we good with 29? Okay. This is a related rates problem. This is a nice one. Okay. So if we have to have a related rates, this is a good one to have. So I got to take a derivative with respect to time. It gives me dx dt. It looks like I got to find dy dt. So, and then they give me some x values that I've got to plug in. Okay. So what's the derivative of y with respect to time? Good, dy dt. What's the derivative of 4x squared with respect to time? Dx dt, and then plus 0, which I'm not going to write down. All right, there were two cases. I had to check it for 2, and I have to check it for 4. So for x equals 2 and for x equals 4. dy dt equals dy dt equals. So I'm going to plug in it. I have 8 times the x value of 2, and then my dx dt is also 2. And then I've got 8 times 4, and my dx dt is 2. dy dt. It's t because look at what they want. They want me to do with respect to time here. Okay. All right, so 8 times 2 times 2 is 32, which I don't know what. See, this is why I hate sometimes the test generators. Can't I get the answer based on that? Why did they give you the second value? All right, so likely on the test, I will wipe out the second value, but just in case. So let's see. 8 times 8 is 64, so it's definitely B. I don't understand why they give you more work just to give you more work. That's silly. I don't know. All right, good old cone. All right, you ready for it? Okay, conical tank, draw the picture. Okay? Draw the picture. 12 feet across, which means the radius is how big? 6. All right. 13 feet deep, so I know from here to here is 13. I know I'm going to have a radius and a height in there. Okay. It says we're flowing into the tank at 10 cubic feet per minute. 10 cubic feet is what? Cubic. That's related to dV dt. It's 10 feet cubed per minute. Okay? Find the rate of change of the depth. The rate of change of the depth is dH dt is what we're trying to find. When the water is 6 feet deep, so when our height at that moment is 6. You'll notice that there is no formula. You need to know it. Okay? I'm going to put it down here so I have enough space. So volume equals, good, pi, perfect. All right, where you've got two variables and we have to use a product rule. And I like to write it, instead of 1/3, I like to write pi over 3, right? Just because it eliminates some of the numbers I have to write down for this thing. All right, so let's go with dV dt. So I'm going to keep the first, which is pi over 3 r squared. What's the derivative of the height? dH dt. Plus, keep the pi over 3, keep the second. What's the derivative of the first? Good. You guys, the derivative is the same every time. You could memorize it. Okay? I know. It's the same every time on this problem, right? You know the problem's going to be on the test. All right, let's put in our values. So I'm going to put in the 10. I've got pi over 3. The radius at that moment, do I know that? No. So let's come back to that. Do I know dH dt at that moment? That's what I'm trying to find, right? Plus pi over 3. Do I know h at that moment? Yes, 6. The 2 is a 2. I don't know r, and I don't know dr dt. So that's where the rate that we have to come up with another equation. So that's where we set up the proportion on the triangle. So if I do r over h equals what over what? 6 over... Yeah? 6 over 13. Perfect. All right, I'm going to cross multiply, right? Actually, let's see. We want to solve for h, don't we? We want to solve for r.
Yeah.
So let's just multiply the h over. 6 over 13h. I know I need a derivative at some point, so dr dt equals 6 over 13 dh dt, which I'm going to sub in here for the dr dt, so 6 over 13 dh dt. I still need to find r, don't I? Do I know the height at that moment?
Yes.
Yeah, so can't I plug in 6 into that? So r equals 6 over 13 times 6. What's 6 times 6? 36 thirteenths. Just got really great, didn't it? 36 thirteenths. 36 thirteenths. 34. Okay. All right. It looks like at that point you're going to have your calculator, aren't you?
Yes.
Yeah, so couldn't you do your canceling and your... What's going to definitely end up in the denominator? Pi, right? So I would probably use my calculator to go ahead and finish it. Okay? So, and I know that eventually I'm going to have pi in the denominator. All right, I'm not going to keep I'm not going to keep going because I want to get through a few more problems here. All right? Good news is we're getting rid of 32, right? Yay, you don't even have to do it for the homework. All right, and now we move on to critical numbers. Yay.
Even better.
Even better, right? Because critical numbers means I do what? Derivative and set it equal to? 0. Okay, it looks like unfortunately I have a product rule. So keep the first. It's really 14 minus t to the 1/2. So derivative of the second, what do I put the 1/2? To the front. And then I have 14 minus t to the negative 1/2. And then plus, keep the second, and I'm just going to keep it in radical form. 14 minus t. And then the derivative of the t in front is what? 1. Okay, I'm going to clean this up. So I'm seeing a t on the top. This whole thing's going to go to the bottom under a radical sign. It looks awful, but it's really not going to be that bad. Okay, plus the square root of 14 minus t. I'm going to set that equal to what? 0. I'm going to take this and move it to the other side by subtracting. Square root, you can do that. It's okay. All right. In order to get rid of this mess, don't I multiply by this? So think about that. If I'm multiplying by 2 square root of 14 minus t, I have a negative 2, and then this radical times that radical is just the junk underneath, isn't it? See, it looks a lot better now. All right, I'm going to distribute. So we've got t equals negative 28 plus 2t. Subtract the 2t over, so I've got negative t equals negative 28 or 28. What happened? Something went wrong. What happened? We lost a step somewhere. Had to have. Let's see. We subtracted 1 off the exponent, right? We did that right. Oh, I know where there's a mistake. We didn't do the chain rule, did we? Chain rule would have made it negative, right? Which means I have a negative here. Which means there's a negative there. That's at least part of our problem. Which means there's a negative here. So it ends up being... There's our 3, isn't it? That was the whole mistake, was losing that sign. So what happens now when I bring the t over? When I subtract 2t over, don't I get negative 3t? It's still going to be negative 28. So we end up with 28 over 3, right? So it ends up being c. But we could also set the denominator equal to 0. So 14 square root minus t equals 0. So let's see, that would be square root of 14 minus t equals 0. 14 minus t equals 0. It's not up there, is it? Was one of our choices. Probably because it's outside the domain. Right? Maybe. Because it says that it has to be less than 14, and 14 is bigger than 14. Or is equal to 14. Okay? Alright. Let's see if we can get in. Oh, wait, I don't know what time it is. It's 4:12. We should be at home. Alright. We're only... No, can't go home. If I have to be here, you have to be here. Alright, absolutes. Likely you will see an absolute. It's the only one on the review. We'll probably throw one in there. Okay? Remember, for absolutes, you have to test you have to take the derivative, do your, you look for your maxes and mins, and then you also have to test your endpoints. Okay? So, I'm going to take my derivative and find my critical points. So what's the derivative of that thing? Good. So I'm going to set that equal to 0. We've got 3x squared equals 12. X squared equals 4. X equals plus or minus 2, right? Because I have to take square root. So now, instead of doing the sign chart, because we're seeing the word absolute, that's where we test back into the original function, and we put in our 2 endpoints and our 2 critical points, or however many critical points there are. So I'm going to find f of 0, f of 4, f of -2, and f of +2. And if you kind of look at your answers, you could almost guess what they are. But you do have a calculator. All right. When I put 0 in, don't I get 0? Yeah. Okay. I put in a 4. It says 4 should be turned out to be 16, doesn't it? Yep. So I'm going to go with that. All right. Does it show -2? No, it doesn't. All right. So -2 must not be that important, but let's put it in just in case. So that's -8. -12 times -2 is +24, isn't it? So what's -8 and +24? +16? Interesting. What happened? Alright, and then 2 should turn out to be -16. Did I do 2 cubed was right? 224 is right. Yeah, I don't know why it's coming out twice. Oh! Is -2 inside the interval? No, that's why it doesn't work. Okay. Alright, so what has to be the max in the interval? Yep, and then your min has to be the -16. So max is the 4 and min is the 16. Alright, let's see if we can get through 1 or 2 more here. We had to go to 38, is that right? Yeah. Okay. Identify the open intervals where the function is increasing or decreasing. Again, you're probably going to have your calculator open if you remember how to do it that way. I'm going to show you how to do it by hand. Okay, because this one shouldn't be that bad by hand. Alright, so what's my derivative? Good. What am I supposed to do to get critical points? Good. So 10x equals -2. X equals -1/5. That makes sense, right? Look at your answer choices. Alright, so now I have to do my good old sign chart. Remember, I always go from 0 to infinity. Got a -1/5 hanging out in there somewhere. When I plug in, I'm plugging into my derivative. What numbers between... I did that wrong, didn't I? Should be -infinity to infinity. I don't know why I put 0. Alright, what numbers between -infinity and -1/5 that we should test? -1 works. Could I use -10? Yep, that works too. Alright, when I put a -1 in there, do I get a positive or negative answer? Negative. So that means the first interval is decreasing. That looks good, right? Alright, what about, what's bigger than 1/5? How about 0? Even better, right? 0, what do I get out of this? Positive. So it looks like the increasing, so it looks like answer choice A. Alright, we still got time. Let's do another one. Oh boy. Let's look at 37. Okay. We'll go back and do 36 on Monday, okay? Let's look at 37. The graph shown in the figure, sketch the graph of the derivative of f. Okay. So this is the original we need to get to a derivative. Well, one of the things you could do is count the humps, right? And go down by a hump. So 1, 2, 3. So I need to have only 2, right? So which 2 do I get down to? It's got to be either B or D, right? This is gone. It's never going to be the same as it is, okay? Well, I take that back. There is, but we're not ready for it yet, okay? There is one thing we take the derivative of and we get itself, okay? We'll see it in chapter 5. All right, so looking at where I've got, all I really need to do is decide really if it's decreasing or if it's going down or going up, right? So it's decreasing, so I should be above the axis or below the axis to start? Below, so it's got to be D. All right. All right, let's see what 38 looks like. Oh, that one looks ugly too. We'll save those 2 for Monday. Okay? So you guys got to remind me, we got to do 36 and 38 on Monday. Okay? All right. Remember, Tuesday is the last day to turn in any homework. Okay? Think about it. We do have a snack bar next Thursday. Even though it's a half day, there is a water polo game. So I have one person